Introducing DuPont's Dimension Clinical Chemistry System, a fully automated, discrete, random access system which features 37 routine and specialty chemistry tests with stat capability. The system uses DuPont's low-cost per-test reagent cartridges, disposable cuvette system, and ion-selective electrodes to provide rapid, accurate, and precise test results with ease of operation. Let's take a brief look at the components and features of the Dimension system. Test processing begins at the operator interface area. Components of the operator interface area include a 12-inch color monitor, a typewriter-style keyboard, a thermal printer, and a dual disk drive with battery backup. Drive A contains the operating system. Drive B serves as backup for Drive A and also contains diagnostics and training. In the event of a power failure, a battery powers the disk drives so that all information can be transferred to disk. Let's examine the main operating menu display, looking first at the instrument status boxes. Boxes are color-coded to indicate instrument status: green for go, red for stop, or yellow for caution or busy. Error messages are displayed on the error message line when a system malfunction occurs. The operator interacts most frequently with the applications area of the display, entering and retrieving information throughout the operation of the Dimension system. For example, this area is where sample data is entered and tests are requested. Should the operator require applications information, pressing the Help key on the keypad will display help information in the message area. The message area also displays query messages and attention messages. The bottom two lines of the screen display are the soft functions area. These functions are redefined as each new screen display appears. Let's now examine the keyboard. The top row of keys is for test method selection. Each key has two methods assigned to it, with the second method accessed by the Shift key. The center section of the keyboard is typewriter style used in entering alphanumeric information. Patient information can also be downloaded from a laboratory host computer through the instrument's interface port. The function keypad contains the soft function keys F1 through F8, which correspond to the soft function blocks on the screen display. The function keypad also contains the alarm on-off key, help key, exit key, and cursor control keys. The next major area of the Dimension system is the sample area. The three main components of the sample area are the sample wheel, sample arm, and sample drain. Patient samples are loaded into disposable sample cups of either 1/2 or 2 milliliters sizes. Patient sample requirements range from 2 microliters to 60 microliters for photometric testing, and 110 microliters are required for electrolyte testing. The Dimension system provides 2 removable sample wheels, A and B. Up to 60 samples may be loaded on each wheel, with positions 56 through 60 being reserved for stats, although any cup can be assigned as a stat. Sample cups can be loaded onto a sample wheel at a workstation or on the instrument. When the sample wheel is loaded and the test process begins, the wheel moves the desired cup into sampling position. The sample arm pivots to draw a precise volume of sample, stopping at the sample drain where the outside of the sample probe is vacuumed to provide accurate sample delivery. The sample arm now transfers the sample to a cuvette, which the reagent arm has filled with the appropriate reagent. The sample arm ultrasonically mixes the sample and reagent. The sample arm pivots again to the sample drain where it is flushed and vacuumed inside and out to eliminate carryover. This step occurs between each sampling. The second major component of the sample area is the ion selective electrode, or ISE system. This independent station allows electrolyte testing on serum or urine to be done concurrently with photometric measurements. The ISE system is composed of its own sample arm, an electrode stack containing sodium, potassium, chloride, and reference electrodes, a separate TCO2 electrode, a peristaltic pump, 3 standard bottles, and 2 reagent bottles. In electrolyte sample processing, the ISE sample arm aspirates samples from the sample wheel. The sample enters the electrode stack, which measures sodium, potassium, and chloride. The sample is then pumped to the mixing block, where it is mixed with TCO2 release reagent. This mixture then flows into the TCO2 electrode, which measures total carbon dioxide. Each sample measurement is followed by the measurement of an internal standard to check for drift in the electrodes from the last calibration. In addition, the ISE system automatically performs a 2-point auto-calibration every 2 hours. Salt bridge solution recirculates throughout the reference electrode housing, completing the electrical path for measurement of the ion-selective membrane potentials. The peristaltic pump moves fluids throughout the ISE system, both during and after the testing phase, and sends the used sample solutions to the ISE waste container. Now let's take a look at the reagent area of the dimension system. There are 5 main components of the reagent delivery system: the reagent tray, the reagent arm and probe, the reagent cartridge shuttle, the barcode reader, and the reagent cartridges. The dimension system uses a unique self-contained reagent cartridge, the Flex reagent cartridge. Flex cartridges come in either 8-well or 6-well sizes. Reagents contained in the wells may be either liquid or tablet form, with enough reagent for 15 to 240 tests. Encoded on the barcode label of each Flex cartridge is information pertinent to its reagents. This information includes the method, lot number, sequence number, and expiration date. Flex cartridges have a refrigerated shelf life of up to 1 year, and if stored unopened, a 1-month expiration on board the instrument and up to 3 days expiration after a well is opened. The refrigerated reagent tray will hold up to 45 Flex reagent cartridges, giving the operator method and lot flexibility. Adding or removing Flex cartridges from the reagent tray is a simple process. New Flex cartridges are inserted in the reagent shuttle and pushed forward into the tray past the barcode reader. Flex cartridges are removed in the same manner. When Flex cartridges are inserted or removed from the tray, the barcode reader scans the barcode information and stores it in inventory. The dimension system then uses this information to calculate the number of tests available, expiration date, and calibration status. The reagent arm prepares and transports reagent from the Flex cartridge to the cuvette. The probe uses ultrasonics to mix reagent with sample or other reagents already in the cuvette. For certain methods, the reagent arm prepares the Flex cartridges that contain tablets by adding water to hydrate and dissolve the reagent ultrasonically. Also, 2 or more liquid reagents can be mixed together in an empty well to form working reagent. A vacuum drain system travels with the probe to eliminate any reagent carryover. By flushing, rinsing, then vacuum drying the probe, reagent integrity is continually maintained. Another unique feature of the dimension system is the internal manufacture of small, disposable cuvettes in which the reaction takes place. A cuvette film cartridge contains 2 rolls of Serlin film, which is enough to form 12,000 cuvettes. The first layer of film is warmed and blow molded against a quartz window on the cuvette wheel. The second layer of film is then heat bonded to the first layer with a U-shaped seal. The optical quality of each newly formed cuvette is checked and ensured by a photometric reading before the cuvette can be used in processing. When the reaction is complete and readings have been taken, the cuvettes continue around the cuvette wheel until they reach the top seal. Here, the top edge of the cuvette is sealed to contain biohazard waste within the cuvette. The used cuvettes are then fed into a waste container beside the film cartridge housing. The main control system of the instrument is located behind the lower left-hand side door. The control system interfaces the power supply and the computer system to control all aspects of instrument operation. The main power on-off switch is located on the AC power board on the extreme lower left. The computer system control boards are located above the AC power board in the card cage assembly. Moving to the right of the control boards is the syringe panel, which has 4 Hamilton syringes used in sample and reagent metering and sample and reagent flush to ensure precise delivery of all system fluids. Just below the syringe panel is the purified water diluent, the only diluent used on the Dimension system. The waste containers for chemistry and ISE fluids, located beside the diluent bottle, are self-contained on the instrument, providing easy disposal and maximum insurance against biohazard contamination. Opening the lower right-hand door on the Dimension system reveals an onboard compressor which supplies air pressure and vacuum used by the system. The thermal chamber houses the source lamp, photometer, and cuvettes to maintain a cuvette temperature of 37 degrees centigrade throughout the reaction and measurement cycle of processing. This concludes the overview of the Dimension Clinical Chemistry System, a system that makes test processing simple, routine, and easy. The Dimension System, offering total integration in a clinical chemistry system, exceptional precision, accurate results, low maintenance, and proven reliability. The Dimension Clinical Chemistry System from DuPont.